Hi folks, Mr. Long here. I am just going to go through a few parts of your assignment for you to make sure that you know what's going on. All right, so we'll go through that. So the first bit is question number 1, and the one question that I'm having is number 1F. What is the total distance traveled by the particle in the first 3 seconds? So for that question, I'm just going to go into Desmos, and I've just got a curve on the screen here right now, and this will give you an idea. So let's assume that this is a position versus time graph, or an S of t graph. Okay, an S of t graph. Whoops. Okay, I've got a curve back here. I just got rid of my curve by accident there. Okay, so let's take a look at this curve. And if the question was, how far did this person walk, or how far did this particle move in the first 5 seconds? Okay, so what we'd have to look at 0 seconds, the person was, or the object was 2 meters to the right of the origin. Okay, 2 meters to the right of the origin. And then at this point right here, they are at the origin. So at 0.354 seconds, they're at the origin. So from 0 to 0.354, they had to walk a total of 2 meters. And then they walked down here another 7 meters. So if you look, they walked 2 meters to go from here, from 0 seconds to 0.354. Then it took them another 7 meters to get here. Now they're 7 meters to the left of the origin. And then within the first 5 meters, it looks as though they got back to, at 5 meters, they are at -3, a position of -3, so 3 to the left. So in total then, they walked 2 meters to get to the origin, an additional 7 meters, so that makes 9 meters to get to their minimum position, and then they walked another, in this case, they walked another 4 meters to go from -7 to -3. Okay, so 2 meters plus 7 meters is 9 meters, plus another 4 meters is 13 meters. So that is their distance they traveled, if this is an S of t curve. Okay, distance is not a signed quantity, it's always positive. Displacement is a signed quantity. Okay, so that's that question. Oh, and some people have asked about the tangent as well. The tangent, you just use your f prime at a, y equals f prime at a times by x minus a, plus f at a, and do your tangent that way. Now you can certainly put the tangent on Desmos, but I would like to see that mathematical development of the tangent. I do want to, and there's one little edit here, compare the area under the curve between 0 and 4 seconds. That should be area under the velocity curve. Okay, area under the velocity curve between 0 and 4 seconds. Now you can do that on your black calculator and in class. Alternatively, on Desmos, I believe you can do it on Desmos. And if you go to functions. So if you go to functions, miscellaneous, and you do that, so it will calculate area under the curve for you. So if I had a curve here, I have an f at x curve, for example. I could do area under f at x between 0 and say 5 seconds, and then I would just write f at x. Yes, I think. And it gives me a quantity. There you go. Okay, so that's the answer to that. That's the area under the curve. So you can do that on Desmos, or you could do it also on your black calculator. Okay, so let's go to question 2. Question 2, and if you notice question 2, it says their calculator active for regression, derivatives, integrals, and solver features. So in the first one, you have to do some regression. So to do regression, you can do it in your black calculator, and there is a screencast on the Mr. Long Happy Math in the technology section on how to do that on your black calculator, but you can also do it with Desmos. I'll quickly show you that. If I had a table of values, as you can see right here, I do have a table of values here, and I'll turn that off. So there's a scatter plot, okay? If I want to get a quadratic curve through that scatter plot, then what I can do is I put x1 and y1 as my table of values, and then I write y1 equals, and this is approximately equal, right? That's why it's a regression symbol. And to get that regression symbol, actually, you hit the ABC button, and then if you look, it's called an ampersand, I think. It's this squiggly thing. It's proportional to is the meaning. So what you do is you do that, and it will tell you what the equation is. So in this one case, it's going to be x squared minus 4x plus 3 is the equation that fits through that curve. Okay, that's the regression equation. So that's the way you do that with Desmos. Okay, then in terms of the question itself, you're going to need certainly the original function, you're going to need the first derivative, and you might even find you need the acceleration, the second derivative. I find the easiest way with Desmos actually to do the derivative is to just write your f of x curve, and then you just have to write f prime of x and f double prime of x. So this would be, the f prime of x would be your velocity, and then f double prime of x would be your acceleration. Okay, so that's how you get those curves. And then you need to start using the curves. So some of the questions, first thing you have to do is get the skill rating, the thrill rating rather, and it gives you maximum speeds. What you need to remember is that speed is neither positive nor negative. It's always positive. So you need to find a location on your curve when the ride is traveling the fastest. Okay, when the ride is traveling the fastest. And you can do that by looking at your velocity curve. So, for example, what I'll do here is I will get rid of the position curve or the height curve and get rid of the acceleration curve and look only at the velocity. So in this case, folks, at 0 seconds here, you can see that for this curve, at 0 seconds, the velocity would be 5 meters per second. That's also a speed of 5 meters per second. Similarly, though, if I went down here to 1.22 seconds, or about 1.2, 1.23 seconds, the speed would also be 5 meters per second. Because if the velocity is -5, the speed is 5. So in your case, once you get that velocity curve plotted, you're looking for the maximum speed, which is the fastest velocity, right? So it can be positive or negative. When does braking start? After 3 seconds? Well, or does braking start after 3 seconds? Well, you're going to have to look at the curve and imagine what happens when a vehicle brakes. Okay, so what happens to the speed of the object after you put brakes on, right? And I think you'll be able to tell, and you'll be able to describe what sort of feature that is on the curve. Okay, so in the last question, again, you need to do regression. And there is a little correction here as well. My apologies. Instead of being the curve, it should not go 6 and 3. A number of students have already spoke to about this, but that should go 3 and 6, not 6 and 3, of course. You're going to approximate the derivative. You're going to approximate the derivative using the data in the table. So you've got to, approximate